Welcome to 9.1, Right Triangle Trigonometry. Within this section, we're going to be taking a look at our 30, 60, 90 triangles, 45, 45, 90 triangles. We will also be reviewing how to go from a degree to a radian and vice versa as far as the conversions. And we are going to be taking a closer look at how to work with our word problems as well as problems of elevation as well as depression. Let's go ahead and take a look at slide 2. In slide 2, we begin with our 6 trig functions. So we have sine, cosine, tangent, and their inverses, which are cosecant, secant, and cotangent. Now, one of the acronyms that are known to be very popular in order to remember your sine, cosine, tangent, and the direction in which you would look at within your triangle would be SOHCAHTOA. SOHCAHTOA is spelled SOHCAHTOA. Now the first letter of each one of those three words represents the sine, cosine, and tangent, and the following letters OH represent the direction in which you would be looking for the numerator as well as the direction you would be looking at for the denominator. So in sine, we would be looking at the opposite of the degree over the hypotenuse. Now, if we take a look at the image that is on the right-hand side, we can see that our angle is angle A, which is located right over here. Our opposite would be directly across from it, and our hypotenuse will always be the diagonal line, in this case between angle A, and angle B. As we go ahead and take a look at cosine, our cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. Now, this is not a firm place within your triangle. Depending on the angle that you are looking at, if we change the angle from angle A to angle B, we would now have new numbers and new locations because it is based off the angle, not a fixed place. The only line that is a fixed place would be the hypotenuse. Now, in order to understand the difference between sine and cosecant, which are inverses of each other, you can see that the directions are the exact opposite of the sine. So in sine, we're doing opposite over hypotenuse, and for cosecant, it is the hypotenuse over the opposite. Once you have calculated the opposite over hypotenuse, you can actually calculate the cosecant by doing the reciprocal of the opposite over hypotenuse. So in this case, you would do the hypotenuse over opposite. And this can be copied for each one of our inverse trig functions. Let's go ahead and take a look at slide 3. We're first going to begin with taking a look at our first example, which is a triangle which uses 45, 45, 90. Now, as we stated before, we would use our acronym of SOHCAHTOA. Generally, what I would suggest is for each trig function, you go ahead and write the directions in which you would be looking. Now, keep in mind, we are going to be going off of the given angle, which is 45. For sine, it would be the opposite over the hypotenuse. In that case, the cosecant would be the hypotenuse over opposite. For cosine, we have adjacent over hypotenuse, which means the secant would be the hypotenuse over the adjacent, and tangent would be opposite over adjacent, and cotangent would be adjacent over opposite. This is extremely easy to go ahead and write out just to be sure that we are understanding what it is and the direction we would be going for each one of our 6 trig functions. Once we go ahead and find our sine, cosine, tangent, we can then do the reciprocal of our initial values. Now notice we're saying initial values. It may be that you need to go ahead and simplify it further by removing the square root or cube root, whatever it may be, from the denominator and moving it to the numerator. So let's go over our sine of 45. In this case, the sine of 45 would be opposite over hypotenuse. Opposite would be at the 1. Hypotenuse would be at the square root of 2. And the adjacent would be 1. So in this case, opposite over hypotenuse would be a 1 over the square root of 2. Now, once we've grabbed our O and H, we can go ahead and actually write it down for our cosecant. Remember, we are doing the reciprocal, so H over O, which would be the square root of 2 over 1. Let's go ahead with cosine. In this case, cosine would be looking at the adjacent over the hypotenuse. Adjacent would be 1. Hypotenuse would be the square root of 2. The inverse of it would be the square root of 2 over 1. Lastly, we have tangent, which is opposite over adjacent. Opposite would be 1 over 1. And adjacent over opposite would be, once again, 1 over 1. Once we have the positioning of each one of our directions between our opposites, our adjacents, and our hypotenuse, we go ahead and simplify wherever we can. Now, in order for you to simplify, you would have to go ahead and multiply by the square root of 2 over 2. This would cause you to have the square root of 2 over the square root of 4. Keep in mind the square root of 4 would give us 2. And that would be our final answer. Now keep in mind for the cosecant, we have the square root of 2 over 1. We would not have to simplify it here because we do not have a square root in the denominator. We go and drop down to the cosine of 45. In this case, we go ahead and rationalize the denominator, which is multiplying by the square root of 2 over the square root of 2. In this case, we would end up with the square root of 2 over square root of 2 times the square root of 2 is square root of 4. Square root of 4 would give us 2. Notice for secant, tangent, and cotangent, all of these trig functions do not have to be rationalized because there is not a denominator that has a square root. We can go ahead and simplify these answers. So keep in mind, for cosecant, our answer would be square root of 2. Secant would be the square root of 2. Cotangent would be 1. And tangent would be 1. Let's go ahead and take a look at our second problem. In our second problem, we're now looking at a 30, 60, 90 triangle. Now notice we are focusing on the 60-degree angle, which you can see is on the bottom right-hand side of that triangle. Once again, we continue with sine, cosine, tangent, and their inverses. Our sine would be the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Keep in mind, our inverses are the reciprocal of each one of those. So in this case, h over O, h over A, and A over O. So once we go and find our 60-degree mark, we go ahead, label our triangle. In this case, the opposite of 60 would be the square root of 3. Our adjacent would be 1, and our hypotenuse would be 2. So in this case, our answer would be the square root of 3 over 2, which means that our cosecant would be 2 over the square root of 3. Keep in mind, in this case, since we're going to go ahead and multiply by the square root of 3 over the square root of 3, our final answer here would be 2 square root of 3 over 3. Now the 3 in the denominator, remember, is due to square root of 3 times the square root of 3 is going to give us the square root of 9, which gives us 3. Adjacent would be 1 over the hypotenuse, which is 2. So 1/2 is our answer. In this case, hypotenuse over adjacent would be 2 over 1, or 2. Our tangent is the opposite, which is the square root of 3, over adjacent, or the square root of 3. Cotangent would be the opposite, or the reciprocal of it, which would give us 1 over the square root of 3. Once we rationalize the denominator, that would actually give us the square root of 3 over 3. Our last example here, we are first finding the angle of A. Now all of our triangles will equal 180. So in order to find angle A, this would be 180 minus 90 minus 27. In this case, our answer here would be 63 degrees. Now, as we go ahead and work for side B, first thing that we have to realize is we are being given specific information. That first piece of information is the angle, which is 27. We are looking for B, and we have to include one more piece of information that we know, which in this case is us knowing that the height would be 6. So in this case for 27, opposite would be B, adjacent would be 6, and our hypotenuse would be C. So considering how we are working with B and 6, there's only one trig function that works with O and A, which would be tangent. So we would go ahead and write the tangent of 27 is equal to opposite over adjacent, or B over A. Correction, not A, that would be 6. In order to isolate the B, we have to go ahead and multiply both sides by 6. That would leave us with 6 times tangent of 27 is equal to B. Now keep in mind, we have to put the place of the 6 in front of the tangent 27. Tangent of 27 is one expression, and we cannot multiply 6 times the 27. This is similar to having a problem such as x is equal to y over 6. In this case, we would multiply both sides by 6. And when we do, we would end up with 6x equals y. Notice our 6 and x cannot blend together the same way that our tangent of 27 and our 6 cannot blend together. They are only getting multiplied by each other. Let's go ahead and take a look at side C. Inside C, once again, we start off with our 27 degrees, but in this case, we have the adjacent and the hypotenuse. This means that the trig function that we are going to use is cosine. While using cosine, this would go ahead and be written as the cosine of 27 is equal to 6 over C. We're going to multiply both sides by C, so we would actually have C cosine of 27 equals 6. Now, in order to isolate the C, which we have been looking to do, we are going to divide both sides by the cosine of 27. Our final answer here would be C is equal to 6 over the cosine of 27. It is extremely important that you go ahead and write the cosine of 27 all together due to the fact that they are terms within one expression. You cannot write cosine in the front like such. Cosine of 6 over 27. This would actually mean the same as the cosine of 6 divided by the cosine of 27. There's a big difference, so please be sure to keep that trig function right next to the 27 in the denominator. Let's go ahead and take a look at slide 4. Here we have a sample problem, and it says, let theta be an acute angle such that sine theta is equal to 5 over 6. Evaluate the other 5 trig functions along with it. So as with all things that we do, I highly suggest we go ahead and draw out our triangle. In this case, we have a 90-degree angle here, and on the bottom right, we have theta. We know that our hypotenuse is going to be at the 6, and it is the diagonal 9. We know that because with sine, it is the opposite over hypotenuse. So once again, hypotenuse would be 6. The opposite would be 5. In this case, it would give us that location. In order to find the missing side, to make it easier for us to work with all 6 trig functions, we would have to use the Pythagorean theorem, which states that a squared plus b squared equals c squared. Now, in reference to a and b, it does not matter which one of the sides you end up using for a or for b, but the one side that does not change is c. C will always be the hypotenuse. So as we go ahead and start plugging in our numbers, this would give us 5 squared plus b squared is equal to 6 squared. 25 plus b squared is equal to 36. We're going to subtract 25, so b squared is equal to 11. And we're going to get the square root of both sides, which means b is equal to the square root of 11. Now that we've found the missing side, we can go ahead and work with our 6 trig functions. Firstly, we would go ahead, find our various sides. So theta, notice is in the bottom right-hand corner, opposite would be 5, hypotenuse would be 6, and the adjacent would be 11, square root of 11. So we go ahead and start off with sine. Remember, sine is opposite over hypotenuse, which would give us 5 over 6. Also keep in mind that part of our problem was given within the word above. Cosine is your adjacent over hypotenuse. Adjacent would be the square root of 11. And that's going to go over the hypotenuse, which is 6. Tangent is opposite over adjacent, which would give us 5 over the square root of 11, which once we rationalize would actually give us 5 square root of 11 over 11. Cosecant is extremely easy. Since we did not have any form of square root in the denominator, we can just grab the reciprocal, and cosecant would be 6 over 5. Secant would be the same thing. In this case, this would give us 6 over the square root of 11. Now that we have flipped their positions, notice we cannot have a square root in the denominator, which would leave us with 6 square root of 11 over 11. Last would be 5 over the square root of 11. Now in this case, instead of O over A, we're going A over O, which would leave us with square root of 11 over 5. Let's go ahead and take a look at slide 5. In slide 5, we have a right triangle with a hypotenuse of 8 inches, and it includes a 37-degree angle as pictured below. Find the measures of the other two angles and the other lengths of the other two sides. In this problem, the first thing that would be easiest to determine would be the angles themselves. We have a 37-degree angle, and we know that when we see this box in the corner, this would be 90 degrees. Now, in order to find our remaining angle, we would have to go ahead and say 180 minus 90 minus 37. And in this case, it would give us 53 degrees. Now, as we find the missing sides, A and B, remember we have to go off the given information. What given information do we have? We have an angle of 37 degrees, and we know that the hypotenuse is 8. Our adjacent would be B, and our opposite would be A. So if we begin first with A, we would be taking a look at opposite of 37, which would give us A, and our hypotenuse. In this case, we would be working with our sine trig functions. So we go ahead and we first start off with the sine of 37 is equal to A over 8. We're going to multiply both sides by 8, and that would leave us with 8 sine of 37 is equal to A. In the aspect of B, keep in mind, we would first have to find what is being given to us. In this case, the adjacent and the hypotenuse. Here, cosine is going to be our best bet, which means the cosine of 37 is equal to the adjacent, which is B, over the hypotenuse, which is 8. we multiply both sides by the denominator of 8. In this case, we have 8 cosine of 37 is equal to b. Let's go ahead and take a look at slide 6. Now, as we start heading into the word problems, I highly suggest that you first read through the entire paragraph as a whole and then determine what important information we have. Here it says the bamboo is the fastest growing land plant in the world and is becoming a popular wood for hardwood flooring. It can grow up to 46 inches per day and reaches its maximum height and girth in one season of growth. Now, up to this point, we really haven't found any piece of information besides that it has the ability to grow 46 inches in one day and can reach its maximum height and girth within one season. But we have to be able to take a look at what we are being asked for. And generally that is the last line of the paragraph. It says approximately how tall is the bamboo shoot. So we go ahead, we continue reading, and it says to estimate the height of the bamboo shoot, a farmer walks off 27 feet from the base and estimates the angle of elevation to the top of the shoot to be 70 degrees. How tall is the bamboo shoot? Whenever we are working with a word problem, the first thing that must be done is we need to go ahead and draw out what we see is being given to us. So in this case, we go ahead and we understand that we are being given the height of the bamboo. Now that farmer is going to walk 27 feet away from the base of the bamboo. It's also saying that it has an angle of elevation, which is about 70 degrees. Now our angle of elevation would be in this corner right here. What we're looking for is the height, which is x. Considering how we have the 70-degree angle, and that would be the opposite, and 27 would be the adjacent, the only possible trig function that would work here would be tangent. So the tangent of 70 is equal to x over 27. As we multiply both sides by 27, our final answer here would be 27 tangent of 70 is equal to x, and that would be our height of the bamboo. Let's go a little deeper into what is actually slightly spoken of within this one slide, which is the angle of elevation as well as the angle of depression. Now, the most important thing to understand is that this is all based off of the point of view of the word problem. Notice in this example, we have a person that is on the ground and looking up at the plane. In this case, we want to go ahead and draw a horizontal line going away from the person. And based off of that horizontal line, you ask yourself, are you having to move up or down in order to look at the plane? In this case, because we're moving our head up, this would be an angle of elevation. Now, in our picture on the right-hand side, we are now taking the point of view of the airplane, which means we draw our horizontal line directly in front of the airplane, and we ask ourselves, is the plane looking up horizontally, or is it looking down? In this case, because it's looking at the person on the ground, it would actually have an angle of depression. It is looking down towards the earth. So notice, both of these angles are congruent with each other, but most importantly, it is the point of view that would give us that answer. Let's go ahead and take a look at slide 8. In slide 8, we have a word problem, and it says the longest zip line in the world is the Zip Rider at Icy Strait Point, Alaska. Its length is 5,495 feet and has a vertical drop of 1,320 feet. Find the angle of depression. First, before anything else, I highly suggest we go ahead and draw out what we are reading from this problem. First thing would be, as we graph, we are starting off at the top of a zip line that eventually goes downward. Now, the line itself is 5,495, and it's saying that the vertical drop is 1,320. Now, in this case, we have to ask ourselves, are we standing at the top of the zip line or at the bottom? In this case, if we are looking at the angle of depression, this would mean that we are standing at the very top of our zip line. So as we draw our horizontal line going out, we're going to quickly realize that our vertical drop is still the same. It's still 1,320. But because we have an angle of depression, our angle would be in this corner right here. If we were looking at an angle of elevation, this would be our angle of elevation. And this would be our angle of depression. We go ahead and set up our trig function. Keep in mind, with this corner, wrong corner, with this corner up here by the angle of depression, we have that. We have the opposite, and this is the hypotenuse. So the only other option that we could use to solve this would be the sine of theta is equal to 1,320 over 5,495. As all things, whenever we have a variable and we have a number attached to that variable, we would divide by that number. The same thing occurs here with sine of theta. We want to get the theta by itself, which means we are going to have to divide by sine. When we divide by sine, it is the same thing as multiplying by its inverse. So we would actually have theta is equal to the sine inverse of 1320 over 5495. This right here would be our final answer. Highly suggest to review the given slides. If you have any questions, feel free to reach out at any point.